Now we're going to pick up where we left off. So we were talking about direct and indirect measurements. Again, there's nothing wrong with an indirect measurement. You simply have to realize that you're measuring something and inferring what you really wanted. And so, again, there's nothing wrong with that. Units. You measure something and then you want to be able to explain to somebody else what you measured. So, how big is something? You would have to have some set of units. You know, how long is a piece of wood or board or something? So you're building something and you want to measure a piece of wood to fit. So you need to know how to measure it. So this is you need some unit, and we need to define a few units. So we define units. At one point, I mean, everybody defined things differently, and this was really a problem that units were defined historically locally. For example, you would go somewhere and you'd say, well, how big is this? You know, even in the early part of the United States, you would measure something in feet and inches. Well, the problem is a foot was defined in New York to be a slightly different length than a foot was defined in Georgia, which is slightly different than a foot in Florida. So each state defined their own units, but that meant that there was a mismatch of units between one state and another. Well, that's very confusing. And that kind of confusion is not very conducive to a unified nation. And so that's why one of the basic government functions set up at the very beginning of the government, even in the Constitution, was the authority to define units for commerce, so that we all mean the same thing. When we say 4 feet 6 inches, we all know exactly how long 4 feet 6 inches is. It's the same everywhere. And so, and then you want to define units of volume, units of this, unit of that. Well, ultimately, what we define are what we call fundamental units. A derived quantity is something we get from the fundamental. So for example, a fundamental unit might be length. So we say that something is so long. But what about area? If I want to know the area of the computer screen or phone screen or whatever it is you're watching this on, how do you find the area? Well, length times width. Well, and then you multiply. Yeah. Well, wait a minute. What's width? Well, width is just length sideways. So it's two lengths. So area would be an example of a derived quantity. Likewise, volume is an example of a derived quantity. You would find the volume of something length times width times height. Even the units we use. Unit of area, square inches. Unit of volume, cubic inches, cubic feet. These are all units. You know, you define what a foot is, and then a volume is so many cubic feet. Time is a fundamental thing. When? A difference in time is fundamental, but velocity is derived. So this is a certain distance divided by a certain time. Miles per hour, feet per second, centimeters per second, kilometers per hour. That's velocity. Okay, mass. Mass is a fundamental thing. So this is a property of matter. It has a certain amount of mass. Density, that's mass divided by volume. So we would define a unit of mass. If we can define specified units of length, time, and mass, it turns out that we can get area, volume, velocity, density, even energy or force. Basic unit of force is a Newton. A Newton is a kilogram times a meter divided by a second squared. Energy of units of energy. Basic unit of energy is a joule. A joule is a kilogram times a meter squared divided by second squared. Unit of power is a kilogram meter squared divided by second cubed. So even power, the basic watt unit of power is based on the definitions of these things. So those are the things we really need to have good definition. Well, the British Imperial units, basic length measurement is a foot. So you define a foot. A yard is 3 of them. An inch is 1/12 of one. A mile is 5,280 of them. I mean, we've got time. The basic unit of time is a second. So we define how long a second is. Say a minute, 60 of them. And then an hour's 3,600 of them, so it'll be 60 minutes. Basic unit of mass is a slug. Not a pound. Pound is a unit of force. But a basic unit of mass is a slug. And so these are the British Imperial units. What's another system? One that we often in this country call the metric system, though that's actually kind of silly to me because metric simply means measuring. Any system of units is technically a metric of some sort. It's just maybe not a very good metric. So the international system, we often call this the SI system for the French version of international units. The basic unit of length is a meter. Basic unit of time is second. Basic unit of mass is a kilogram. Now, these definitions, again, foot, how long is a foot? Anecdotally, the length of a foot, was kind of similar to the length of the king's foot. I mean, it's whatever. Okay. A second, historically, they divided the day into 12 hours of day, 12 hours of night, and then 24 hours in a day, and then 60 was a sacred number to the ancient Babylonians, so we divide each hour into 60 parts. Those into 60 parts gives you a second. Okay. When the French, after the French Revolution, they defined kilogram and meter and a unit of time. No one liked their unit of time, and so they eventually went back to seconds. The reason is that they did everything in base 10, so you had a day, and then you had a deciday, and a centiday, and a milliday, and then 1/10 of a milliday. It's kind of close to a second. Okay, that was okay, except on the other extreme, you had a decaday. So that means a 10-day week. And so the system only lasted for about 10 years, and then they went back to the old-fashioned second. The second is, if you look in the book, tells you what the current definition of a second is. The old definition of a second was that a second was 1/86,400th of a day. The problem is the length of the day changes over time due to tidal forces of the moon and the sun on Earth. So the Earth actually rotates differently. So they redefined a second much more precisely to be in an cesium atom transition sent at a microwave that oscillates 9,192,631,770 times. And that oscillation, that time it takes to do that, is considered 1 second. So this is the atomic clock. So the second is very carefully defined in that fashion. Okay. Actually, they have an even better way of defining it now, but that's the classic way of doing it. A meter, because light in a vacuum all travels the same speed, a meter is defined to be currently the distance that light travels in a specified amount of time. So that means we have to define time, and then we get to define length. Okay. That's the important part there. So you have to define length. So a meter is a distance that light travels in 299,792,458th of a second. Okay. Prior to that, the French wanted to make a meter 1/10 millionth of the distance between the North Pole and the equator running through Paris, and they made that definition before they even had an idea how far it was. And so they took their best guess, made a little stick saying, hey, this is the length of a meter. That didn't work all that well, and so this is a much better, much more accurate way of doing it. A kilogram was originally defined to be the mass that 1 liter of water has. A liter being 1,000 cubic centimeters. Centimeter you get from the meter. And so a kilogram, now the problem is purity of water would change the density of it, and the temperature and the pressure would change the density of it. So they eventually defined it to be a platinum iridium alloy cylinder, which was kept in Paris, and that defined what a kilogram was. And that has since been replaced in 2019. In May of 2019, they created a brand new definition of a kilogram, which is based on fundamental constants. Now, explaining that is a little beyond where we are right now because we have to explain those fundamental constants, which we get to later on. But we do have precise definitions of these quantities, the SI system, and that defines the units that we primarily are going to be using. Interestingly enough, you say, well, why are we not on this system of units? Well, I'll get to that actually in the next lecture. I'm trying to keep all these kind of short. So I'll pause here for a little bit and then pick up again.